As we were organizing this, everyone we spoke to that we mentioned we were hoping to get Bror Saxburg said, oh, if you can get Bror, you're extremely fortunate. So I think we are very fortunate to hear from Bror today. Reading his biography, you may have sensed this. I don't think there are many people with as many degrees as Bror Saxburg has, two of which actually come from our own University of Washington, so has spent some time in Seattle. And as of, was it this week or last week?
Last week.
Last week, as of last week, Bror is now the Vice President for Learning Science at the Chan Zuckerberg Initiative, having spent a long career at Kaplan as their Chief Learning Officer, and he may tell you a little bit more about that. But without further ado, I'll turn the time over to Bror, and we appreciate your being here.
Thank you so much. What a great day. I came to this wondering whether at the end of this, as I was trying to talk a bit about learning, whether I was going to be contradicting much of what came before. And the great thing is, I think I'm going to end up mostly reinforcing a lot of things that people have said and talked about before. The flavor I'm going to add is indeed based on my experience at Kaplan, which is a very large education organization. It's got 1.5 million students a year spread across 16 time zones, many different kinds of learning, from helping people pick up their very first associate's degree in something like medical assisting in order to get into the healthcare system, all the way up to being the trainers of choice for people trying to study for their national medical licensing exams or learning English language for university success purposes, et cetera, et cetera. So many different kinds of learning. So what we set out to do when I joined Kaplan was to turn Kaplan into a learning engineering organization. And by that phrase, I mean an organization that applies at scale many of the learning science ideas you heard about here today, but recognizing, as you also heard about here today, that doing stuff at scale is not at all the same thing as doing it in the small. So I'm going to give you a bit of an exposure to how we managed to do this across 22,000 employees, a couple of dozen different businesses, and all those different learners. The first thing is, yeah, technology does help a lot, right? That it does new things for you. It can make new solutions more affordable, reliable, available, customizable, data-rich, incredibly valuable. It can also give you new capacities that you didn't have before, whether it's simulations or video or adaptive learning, which is also terrific. And this is a thing that's only just beginning to be picked up, because of the data thrown off from these systems, you can begin to do potentially quite rapid and systematic improvements. You can pilot things more quickly. And I'll tell you some examples of that later on in this. So this is all good news. However, it's not always on point. So technology can scale good and bad learning. So a little thought experiment here, right? Imagine for a moment your worst ever college professor. Just fix the image of that hellacious person in your mind, all right? In the old days, that person could only damage the hopes and dreams of a few thousand students a year. In the modern era, thanks to technology, that person can destroy the futures of millions of people around the planet. A weapon of mass destruction. Win for technology? No, I mean the technology, it makes things more affordable, more available, more reliable, but it doesn't care whether it's any good or not, right? So the first problem is it'll scale good as well as bad learning. The second thing is learners aren't always so motivated by it. You know, people sitting down, especially with a lot of adult learners that we've worked with at Kaplan, you know, dark room, working on things, tired after a long day of work, the baby wakes up. This is, boy, non-trivial to be learning with just technology. So technology by itself may not just give you that. And even things like peer-to-peer work has got some mixed success. The lessons from that, it's not clear when to make that work well. And indeed, in general, we're likely to need expert coaches along the way. We can't just automate this stuff. Somebody else just said this. It's not going to be all robots. We can't. There's real judgment involved in this. And ultimately, the rules of the road are not settled. We don't fully know how to use technology well, and that's part of what we all have to do. So, well, what do we do then? There's good, there's bad, what do we do? So here's the approach that we took at Kaplan and that I'm taking at CZI now as well, more at scale, which is to say, start from how learning actually works. And you guys heard some terrific presentations depending on the sessions you were in, but even the morning session on how learning works. And that's where you want to start. That's the fundamental thing. What do brains and neurons do? Remember, neurons do not follow Moore's law, right? Neurons and our brains work the way they have for the last 50,000 years, even if the technology is accelerating and changing. So you really want to start from where our brains and the learning processes we have actually work. Then use technology along with people and other resources to implement and enhance good solutions. Not any old solution, but good ones. And then use the evidence that you're generating to actually make progress. You got to test at scale. Just like any other engineering discipline, things that work in the small may not work the same when you scale them up. So that's the learning engineering work that I want to walk us through a little bit. Now, in order to actually get this to happen really at scale, you can't just say, I've got the answer, let's do that 1.5 million times, right? There's a few steps in the middle, right? So the way we handled this in my previous company, Kaplan, was to start by exposing people to how learning actually works and some examples, we'll talk through that, then bringing out some training and education to all the people who were building or working on learning, all the learning architects, the learning engineers, so that they had a sense of what to do, knew what to do. And then came the hard work, because you've got all these early adopters, but the point is not just to have the early adopters do this work. You got to get everyone to do the work. And that's its own real work, which we'll talk a little bit about. And then finally, and mixed in all through this, is the evaluation piece. How are we doing? How is this going? And tools for that. So I'll walk through a little bit about each of these things. So the first step is the exposure piece. So the great thing about earlier today is, the science. People have already been talking about it. So I'm going to give you a little sense of the frameworks we've used at Kaplan, but this will be review, which is really great fun. So the basic underpinnings for a lot of our learning work at Kaplan and now going forward to CZI are these notions of there's a working memory component, and that has short retention. It's also quite verbal. That's an important piece. That's where your voice actually lives. The you that is you actually lives there. It's very flexible, but it's very error prone. It's very slow, and it's really narrow. You can't do too many things at once, right? If that's all we had, we'd be in deep doo-doo, as somebody once said, right? Because we couldn't do very much with a system like this, right? The only way this really works as a whole is because working memory is supported in an almost infinite bandwidth channel by long-term memory, which has totally different characteristics. As it suggests, things stick around a long time. If it's been trained properly, it is very accurate and very fast. One of the really frustrating things is it's nonverbal, which means when you master things deeply enough to automate them, to put them in here, you tend to lose track of them. They are obvious. It is clear. I'm a terrible chess player. I'm not saying that to be polite. I mean, I'm like, what does the knight do, right? It's like terrible. So an expert watching my chess pieces is like, didn't you realize your queen was at risk? And I'm thinking, which one is the queen, right? And the other person, and people have done some fMRI things like this, where an expert's visual system actually fires differently looking at a chessboard because of how deeply ingrained patterns and chunks, you heard that term earlier, have actually become. So interestingly, when you think about the development of training programs, it's rare that people spend enough quality time asking themselves, what of this needs to be in long-term memory, and what is a collaboration between working memory and long-term memory? Because the techniques for putting things, as you've heard, and I'll come to myself, the things to put into long-term memory are actually different, right? So another piece of this, so what you just saw there was kind of cognitive architecture. How does the thinking processes work? But just as important to learners is the motivation architecture, right? Those two things have to go together. So motivation, as we used it, and some learning science and motivational psychologists think about it, is you're after these things, results, whether it's work or fluency or tests or good practice or whatever. So to get there, you've got to start, persist, and put in mental effort, right? That's got to happen. Now you notice liking does not appear on this list, right? What leads to learning is that you start, persist, and put in mental effort into well-designed activities. It doesn't matter if you like it or not. That doesn't mean we want everyone to hate what they're doing. I'm just saying, this is the important thing. It's like weights, right? The exercise matters. Whether you like it or not, doesn't. Your muscles will change, right? So we had a very good cognitive psychologist, Richard Clark from USC, help us do a big survey of a lot of literature around what gets in the way of starting, persisting, and putting in mental effort. And he came up with a quite interesting four-part set of things to watch out for. And he and I are trying to write this up as a synthesis we hope to get out by the end of the fall. The first thing that goes wrong, and these are things that we heard about today too, so that's kind of fun. I'm just reinforcing some things. One thing that goes wrong is you don't value what you're doing or how you're doing it. So I'm a dancer in an algebra class. Why am I here? I'm thinking about Swan Lake, right? So to overcome that, you got to find some way to link it. So maybe it's something about dance foundations. You're going to retire as a dancer. You got to figure out how much money you need. That's a modeling issue, uncertainties. Well, now we're doing algebra, right? Second thing that goes wrong is a self-efficacy problem where I'm another dancer in the same algebra class. I just don't think I can do math. Well, if you come bustling over to me and explain how important it is for my future in the dance foundation thing, yeah, I know, my life is over. I get that. I can't do it, right? You're treating the wrong problem, right? The right treatment for a self-efficacy problem is to refuse to go along with it, to say, yes, you can do this math. We just have to back up and find what's missing in long-term memory. We'll make a plan. We'll put in more effort. With effort, you can get there, right? That's how you treat that problem. The third thing that goes wrong is you attribute your failure to something outside yourself. So, who can learn from this teacher? My teacher hates me. Or this textbook, have you looked at it? It's horrible, right? Or a really popular one among all of us, I don't have time. I don't have time. And again, it's not because I don't think it's important. It's not because I don't think I can do it. It's just I don't have time, right? Well, the solution is not to focus on the other two things, because that's not my problem. The solution is to actually focus on, show me your schedule. Let's problem solve around your calendar, right? And part of it is to model, you can solve this. This is under your control, right? That's part of the issue here, is what's in control and what's not. The last one, which is the hardest one of these four buckets, is negative emotional states. If you are angry, scared, depressed, frightened, it's really going to be a tough one to get you to start, persist, and put in mental effort into something complex, right? And again, that's a totally different problem, right? So, you have a cognitive architecture, but no matter how great that is, you really have to think about the motivational architecture as well. And for example, being able to diagnose and treat, if Bror looks like a lump, right? It's not that he is a lump, I hope. It's that one of these things, or maybe several, is wrong. So you got to get under the hood of the lump. Why are you being lumpy? Let's unpack that, right? And again, too few of our trainers, of our faculty, of our teachers actually have any kind of a diagnostic and treatment toolkit for motivation failures. They tend to say, Bror is a lump. But look, lumps get somewhere. I got somewhere, it's okay. So that's the motivation piece. Now, that comes from the research literature. What you can do is then put this into a kind of a process that you can then start to talk to an organization about. And this becomes a simplification. That's part of what engineering is about. You take rich, sophisticated research and try to turn it into something that's interpretable by many people. So in this case, the idea is, well, let's start by deeply understanding expertise. What is it that's in long-term memory, as well as the collaboration with working memory? What do top performers actually decide and do? And there are techniques like cognitive task analysis that can help you do that. Then, once you have your outcomes, think about evidence-based design approaches. What does the evidence suggest about how you can reach those outcomes? And I'm going to talk a little more detail about that in a minute. The third piece is having good measures of where you're at. It turns out one of the things that is missing from a lot of our education and training work are effective measures of learner performance. We often will have glancing blows on what we really intend, which is that you can actually decide and do something in a situation that's happening in real time. Well, we need to get better and closer at that and gather evidence about the evidence. We have to assure ourselves that what we think we're measuring is working the way we intended. So that's the third piece. And if you have all these together and have some technology running, suddenly you can start to do some very fast pilots, as we'll talk about, right? So this is, at a high level then becomes kind of an engineering process, if you like. So just for fun, the evidence-based instructional design piece, it really matters. You can go after that, and there are some great techniques for doing this. And it's based around how learning actually seems to work, arguably in stages. When you first start an area, and again, this is something others have said already today, when you first start an area and you're a total novice, you feel like an idiot because there is nothing in long-term memory helping you. Everything is in working memory, and it just keeps falling off the side. So when I try to do taxes in a new state, it's always a disaster. There's some weird formula. I can't remember what it is. It's on the previous page. I just saw it. I'm such an idiot, right? It's because I don't have anything. I can't hang on to it. How can you help with instructional design for that startup, that declarative stage? What you can try to do is make really clear information displays. Use your visual field to replace your working memory. So you can glance around to remind yourself rather than having to flip pages or dig around. Make it as easy as possible to refill that working memory that's struggling so hard. The second thing then after you've done this for a while, you begin to get some familiarity with it. Now you're kind of in a procedural fluency phase. And here what really helps you is to have varied practice tasks, different kinds of contexts and so forth. And it's actually here that coaching will make the most difference. In the first declarative stage, working memory is completely flooded. So when somebody starts yammering in your ear about the quality of your work, it's like it just bounces off. You can't think about it. You have to be a little bit more into it, a little more comfortable with it to be able to think about what you're doing while you're doing it. And so that's critical when you get the feedback here. And then for those aspects of expertise that can be automated, not everything can be automated, repeated frequent practice builds the automation, builds the long-term memory traces that allow you to do this. And long-term memory is not just simple stuff. So raise your hand if you drive a car. Great, I tried this in Singapore, it was a disaster. Okay, so now raise your hand if you've had the following thing happen to you. You set out for place A, and then you start thinking about the Gates Foundation, vaccines, health, whatever it is, and you look up and you're in place B instead. Raise your hand if that's happened to you, right? Look around, you're not crazy, not for that reason, okay, right? So this happens to me all the time. I'm usually under-caffeinated, so, I ended up at Starbucks or something. So you laugh, you drive away. But think for a second. Who drove you to the wrong place? No, who was in charge of a ton of metal going at 20, 50, 70 miles an hour? Because it wasn't you. You had no idea what was happening, right? Because you went to the wrong place. Well, somebody took you to the wrong place, right? So cognitive psychologists studying expertise show that, yes, these kind of rich, complex, extended information processing tasks can actually become totally automated. It's not just little short things, it's big things, as long as no conditions are violated that match the expertise, right? So getting the matches right. On the other hand, right, no one can write a persuasive essay and plan a summer vacation at the same time, right? That is the kind of information processing activity that requires a collaboration between working memory and long-term memory. You can plan a vacation while you're driving, but you can't write a persuasive essay and plan a vacation while you're driving, right? So other pieces that come out of cognitive science, there's some really great work. This is a great volume, E-Learning in the Science of Instruction by Ruth Clark and Richard Mayer. Richard Mayer is one of the most cited learning scientists on the planet. They're in their 4th edition. They've been basically aggregating together into this book randomized controlled trial information about instructional design, especially technology-delivered instructional design, and turned it into a guide for instructional designers. So this is not a research tome. This is a synthesis intending to guide instructional design. And I won't go, sorry, it's an eye chart. I won't go through all this, but there's things like, if you avoid irrelevant graphics and stories, because people sometimes put those in for interest, if you avoid them, you can pick up 0.8 standard deviation of benefit to learning. If you use relevant graphics to communicate the content along with text, you can get more than a standard deviation of help. If you use scripting your audio in a conversational style for hard things, you can get almost a full standard deviation. And for those of you, who are not like me with a bell curve in your living room, I mean, at cocktail parties, there's nothing like talking about standard deviation to get the crowd going. But for those of you who don't happen to have that, think about what a standard deviation actually means. If you're looking at a 50th percentile learner and you move them by a standard deviation, you have moved them to the 84th percentile. Okay, so those numbers, 0.8, 1, 1.4 standard deviation, this is non-trivial impact. Remember though, those are laboratory studies, right? Your mileage will definitely vary in the field. But as an engineer, I'd rather start from a standard deviation and lose some than start from no idea, right? So beginning from those principles is not a bad way, since they're grounded in these models around cognitive load and working memory and all the rest of it, things that you've heard about today. So, and we can't rely on our intuitions. So this is the part I have approval from Kaplan to actually show this next slide. I assure you, okay, so all right? This is the dirty laundry slide, or one of many, but it is that. So we are Kaplan, I have to get my verbs right. Kaplan is very good at training students for the law school admissions test. One of the hardest parts of that test are the complex reasoning problems. Some of you may remember those. They're really nasty logical puzzle questions with nasty logical puzzle stems. They're just brain breakers. They're really hard, right? So we are very good at training people for that. When the multimedia world came up, we said, piece of cake, we'll make a video of the Kaplan way for learning, and we'll make a workbook. We will solve this problem. Aren't we smart? So we did. But one of our guys who had been trained actually on a bunch of this stuff we've been talking about looked at this and said, a long-form video for a complex problem-solving issue? This is not going to work. And he knew about the work of John Sweller, whoever was doing that this morning about cognitive load and so forth. And knew about that. And John Sweller, along with cognitive load, has been doing decades of work on problem solving and the use of worked examples as a way of helping folks do these things better. So this learning engineer said, this isn't going to work. We got to do worked examples. And of course, the regular Kaplan production people said, ha, what do you know? Everybody loves video. We got to do video. So they ran a randomized controlled trial. This is where scale comes in. Hundreds of students, as you'll see. And so here's the fun part. So on the right, this is students with no instruction at all. They just hit those hard logical reasoning puzzles. Just next to it is the lovingly crafted video plus a workbook. Now, my marketing colleagues at Kaplan told me that Kaplan, worse than nothing, doesn't sing in the market. I don't know how you see it, but I think that's what they say, okay? Now, the good news is, statistically, these two bars are the same. Oh well, much better. Kaplan, good as nothing. Again, I'm not the business guy, right? The marketing guys are like, Bror. So, but these were the worked examples. We built 15 worked examples, and it's literally just a worked out example. We show one of these complex problems. We have an expert annotate on them how he would think it through, or she would think it through. And students literally have 15 of those. And we didn't know what dose to give, so we gave one group 15, and we gave one group a random half of those and said, I don't know, let's see what happens. These two are statistically the same, so that means 8 was enough, and they are statistically much better than either the nothing or the other one. So this is a win for learning science, right? This is applied at scale. This was hundreds of people, but there's one more thing here, two more things actually. One is, look at the amount of time that was taken by a student. An hour and a half to do the video and workbook, 8 minutes to do the work examples, right? Yeah. You study them about a minute each. You do more on the first one, and by the end of it, you're like, I got it. I think I know what they're doing. And let's take it one more step, practically, right? This is 8 PowerPoint slides, right? This is an hour-long professionally produced video and a workbook. There's like 100x, 200x the development cost. So the Kaplan test prep development group was completely flummoxed, right? What are we supposed to do? Because the learning science grounded one, it works better, it takes less time, and it costs much less. But everyone knows video's great. What are we supposed to do? I was like, well, they did the obvious thing. They said, we got to actually ground our learning practices not on our intuition anymore, but if we can find evidence, we have to use that first. And where we don't have evidence, then let's try to use evidence to constrain us, right? Our intuitions are going to get us into trouble, and we have to be aware of that. So another example of this is the second dirty laundry slide. This is the grading of English composition papers, okay? The left-hand bar is what teachers gave their own students, right? These two were two teachers, English composition teachers, who didn't have those students and who graded the same papers. Houston, we have a problem, right? Now, interestingly, the natural thing is to think, oh yeah, they put their thumb on the scale for their own students. But in fact, you don't actually know what went wrong here. It could be the rubric being used for grading is so horrible that the only way you can give an accurate mark to a student is you know the student. If you don't know the student, you know, you just nuke them. So you don't know from this chart which is actually correct. What you do know is you do not yet have an assessment system that will let you do randomized controlled trials to monitor improvement. So this is evidence about evidence, right? And it's like, we got to fix this. And so Kaplan is in the process of actually fixing that. But think about it. Everyone assumes that just having faculty grade is actually a really good way to measure. I've seen gigantic analytic frameworks using, you know, latent trait class analysis and fancy multi-tiered, you know, statistical techniques, all grounded on faculty grades. Like that? That's not going to get you where you need to go. So we have to improve those things too. And you can't just assume that you're going to get it right. So that's the exposure part. So once we'd exposed, we got some people excited. They did some pilots, as you saw. Now you have to start moving towards scale, educate learners. But here, and again, it's very much like what you guys are doing, adults, all the research says, adults have minds too. If anybody needs papers on this, I can send them to you. But that means learning is the same, right, for the adult experts. So it turns out that's going to take some effort to train people on these different components. So what we ended up doing is recognizing, again, this is a bit like Addy, the learning science really drives you to say, focus on your learning outcomes, really define those very carefully so that you can then figure out what is the evidence gathering you're going to do against those learning outcomes, and then keep working your way backwards, right? Whereas conventional instruction often starts from, well, what am I going to talk about on the first day of class? You really want to focus on what do I want my learners to be able to decide and do and come backwards in the design, and then you go forward. So this requires some instruction to make that all work. It also requires a new way of thinking about learning outcomes. So who here knows Bloom's taxonomy? Have anyone here heard of Bloom's taxonomy? Is that a, yes, there's a lot of, right? So Bloom's taxonomy is a little bit like Aristotelian physics. It was a little bit of an armchair exercise by folks trying to be very good and clever without having a lot of evidence about what they were doing. So a few years ago, the guys at Carnegie Mellon University decided to do a bit of an upgrade on this, and they call it their KLI framework. We took that and adapted it a bit, and instead of the classification scheme that Bloom's came up with, this is the way that the instructional designers at Kaplan actually think about this. You start at the top level with complex cognitive procedures. So a skill domain is made up of a bunch of complex cognitive procedures. And by complex, I mean, you know, write a one-page synthesis of 10 pages of information. I mean, you know, a thinking thing. I mean, it's actually, you really got to do some thinking to get it right. Those complex cognitive procedures, they are supported by a whole set of knowledge components. So it's things like facts. Well, there's a whole set of research about how to do fact learning where you need those. And spaced repetition, using them in context. So you want to actually learn them in the context you're going to use them. So the context actually helps you remember, and so forth. There's concepts, which are very different than facts. Concepts are used in an expert mind to classify a situation. Is this a is this a momentum problem, or is this an energy problem in the world of mechanics problems? Once you know which one it is, there's a schema that lets you decide what's important and what's not important. Suddenly what seemed like a hard problem is actually very approachable, and off you go. But you need to learn how to use concepts. It's not enough to know the definition. you got to become very quick at classifying. That's what experts are good at. So that's its own thing. How do you do that? Well, you classify stuff. You get practice doing that. There are processes like the Krebs cycle or engines or whatever where you have inputs that come together and they lead to an output. And again, it's not enough to know the process. What you need to be able to do, this is what experts are good at, they can very quickly predict what the output will be if the inputs are changed. So if you cut off a piece of it, what happens to the output? Or if you double up a piece of input, what happens to the output? And they're also pretty good at the opposite, the diagnostic thing. If I have a defective output, well, where's the likely place in the process that this is broken, right? So process stuff, you can learn, you can train on that. You can do activities to get good at that. And the final thing for experts is principles, where if things are foggy, it's unclear what's happening and how to make it all work, what do you actually end up doing? Experts are the guys and gals who are able to say, I don't know what's going on, but here's the first thing we're going to look at. And often, you can find what those are and write them down as little sentences. But of course, it's not about memorizing the sentences. It's about using them in the fog. And so that's the practice. You have to actually learn and use the principles in the fog. And that requires expert coaching, because there's lots of choices about how to work in fog as an expert. And that's where you need a lot of expertise, right? Some of the stuff like facts, maybe even concepts, you might be able to get away with purely automated stuff. But as you get further down here, you've got to have some expert coaching. So this means training to get developers to understand and classify their learning outcomes, to match them with methods that have evidence-grounded pieces. And so, at Kaplan, and we built a whole set of things around all these different pieces to deliver to our instructional designers and learning engineers. And I think we're going to need more of these out in the world to be able to train folks. It requires real effort. We actually put in a lot of effort in this. There was like a 30-hour virtual training program, and then there was a workshop, and then there was actually a multi-month part-time project where we had small teams of instructional designers who followed the systematic process and were coached by a good evidence-based instructional designer to actually be able to do this at the end. Because again, instructional designers are people too. They need practice and feedback, not just a memo or a book. They've got to actually try it and work through it in order to actually make progress. So once you've got the education, you feel like you're a bit on a roll here. But now it gets really hard when you're trying to scale, because you want to get wider use, build communities, and keep going. So one of the things we did was to start to look across more of our learning environments with a checklist. I'll talk a little more about that right at the end. And so here, it's a checklist grounded in learning science. We looked at 9 top products we had so that we could get a broader view to say, how are we doing to create some energy? And, it's a little bit of an eye chart again, but some of these things, we as engineers, we don't have to worry that they're not complete. So personalization, we didn't have a lot of personalized stuff going on, but that's really expensive to do. So you might do that later. But look at the objectives. Most of them are pretty good, but we had 3 products that did not have any outcomes at all. It's like, how do you do that when you ask the subject matter expert and the outcome is whatever I want to talk about? What else can I help you with today? It's like, wait, what? And that was it. It was just like, yeah, this course has in it what I think should be in it. What's your next question about the course? It's like, that's not it. What do you want learners to decide and do? Well, I want them to listen to me and become good at what I do. Well, what do you do? So needs work, right? Even the assessment side. We're a test prep company, right? So in theory, but even that needed work, right? So this created some real consternation when people realized, whoa, this is not where we need to be. So this created fuel for the general managers to start to say, now hold on a second, we got to get this thing on a better grounding. And so we began, using learning sciences and running some randomized controlled trials. So we converted a whole bunch of traditional online courses that have kind of a read, write, discuss pattern, the standard thing of you'd read some stuff and then post some things and so forth, into a much more learning science-driven piece where we were very careful about aligning the outcomes to the actual work itself. We actually pulled motivation data and used that to flag for faculty who they had to go after and talk to. And we changed the instructor support materials to make sure they kind of had just-in-time support for what they were doing. So we did a whole bunch of things like this, and then ran a pretty large randomized controlled trial. We had 900 students split across 3 courses that we designed in this way. And what we were able to show is that in this randomization, we were able to show that we got a big lift, almost a 30% increase in a success measure of students, where the success was defined as students actually passing the course, mastering the critical learning outcomes, and coming back for more. That was success. Well, this is a big increase. So this caused Kaplan University, where we did this, to say, well, wait a minute. This randomized controlled trial work, the learning science work, we got to get busy with this and do even more of this. And the neat thing about scale is a place like some of those courses in a virtual university, you might have 1,000 students starting every month in some of those courses, right? So that means you could have 5 sets of 200 students each. This could be 5 randomized controlled trials. And then you do it again, and then you do it again. And you keep going. So in 1 year, in theory, and we were not working at scale when I left quite, you should be able to get 50 or 60 RCTs done in this kind of learning environment. You should be able to crack the back of some hard learning challenges because of the scale you're going at if you're using the learning science as a starting point and you have good assessment tools that you're working with there. And so they created a whole portfolio of things that they were testing. Motivation and self-efficacy principles, the use of worked examples again, learning strategies, they were improving their assessments, and on and on. So suddenly you can have a whole portfolio of things you work on when you're able to do this at scale and you have your folks trained to understand what this language is. And we should be able to get there and do more of this. Now, in order to start to get more and more people involved in this, there's another critical group of people you have to get engaged in this. It's the general managers. Right? So it's one thing to have your instructional designers all ready to go and they know what to do, and it's another thing to have the faculty and teachers so excited to use all this, right? But if the general managers are not allocating money and time to build things this way, it all falls apart. So a key piece we did right before I left in the last couple of years was actually engage the general managers in conversations. So these were conversations between the global CEO, the global CFO, and myself. And it was the global CFO who said, if we're going to make this real, we're going to have to do twice a year conversations with the general managers, just like a quarterly business review, but it will only be about learning. Learning challenges, learning trade-offs, learning investments, which meant the general managers had to learn that language in the same way they learned the language of marketing and IT and operations and sales. They're not experts in those, but they know enough of the language and ideas. If a general manager these days came to you and did not even know what a social media marketing campaign is, you would fire them. They don't have to know how to execute it, but they sure need to know that it should be in the mix. And if they're not doing it, they ought to have a pretty good reason why they're not doing social media marketing, right? Well, same kind of expectation on the learning side. They don't have to be learning engineers, but if they're investing entirely in video production and that's what they want $5 million for, they should be fired. Oh, sorry, did I step on anybody's toes here? Oops, sorry. But it just, that's the basic idea. They should have enough learning engineering understanding to make the trade-offs they're supposed to make. So we ended up running these meetings where the idea was they were responsible for being able to discuss learning outcomes in some detail, the assessments they were doing, even instructional design principles. That was the focus for the first round of meetings that we did, actually the second round of meetings. Then in the third round of meetings, once they'd gotten to this stage, in the third round of meetings, since they now had good assessments or were planning those, what pilots are you going to do that will lead to measurable performance improvements for your most important outcomes? And now they all had the language for what this was. And then the final thing, which is coming up this fall, I won't be there, is now how are you using all of your data, to continue to create continuous improvement processes within your businesses? And remember, this is a conversation with a general manager. This is, yes, of course, the learning leaders have to know this, but it's the general manager who now has to talk about this and explain either how much they're investing or why they're not, right, to the global CEO and the global CFO and myself. And the funny thing is that one of the learning leaders said this was a great thing because the general managers realized if they only talked to the global CEO, they could buffalo him on learning. Because he doesn't, I mean, he's not a learning guy, right? He's a lawyer, finance guy. And if they only talked to me when I was the chief learning officer, they could ignore me on money. Because I had no money, right? So, no problem. The panic-inducing moment was when the two of us were in the room together with the general manager and we appeared to agree. That's dangerous, right? But that was the point. That's exactly the point, to make it important and do it that way. Okay, so then finally, you want to get to some kind of evaluation, some way of being systematic about looking where you're going. So I showed this a little bit earlier. There is a sort of a learning science checklist we built. It's actually publicly available. The Department of Education has an EdTech developers handbook. And in there, they actually put a link in. They asked for this checklist, so it's there. And if you can't find it there, come ask me if you'd like. But it's basically got a whole set of categories like this, scorings, and they're a bit detailed. I mean, they really are. Each of them has its own set of simple characteristics underneath it. What is a good assessment? They match objectives and so forth. And we actually tested this. This was actually done in joint work with the Gates Foundation many years ago when they were looking at some post-secondary online courses. And we tested it to make sure it was inter-rater reliable. So it's actually a good tool. You can train people to actually agree on these measures, and that we're now using as part of our information flow. And it involves not just the instructional design, but other things around the motivation, the organization of the thing, and the way integration is used and all this. So it may be of interest to you to do that, or to look at that. And then, once you have that, that's not enough. You now have to use it. So the thing we did was to actually have the teams evaluate each other's work. So we'd have test prep teams evaluating the university courses. We'd have the English language learning teams evaluate something from test prep. So that, and this did two things. One, it gave fresh objective insights to the development team. But remember, these are human beings, right? One of the best ways to cement conceptual understanding is to force the use of the concepts in novel environments. So the evaluators were also using these concepts in an environment unfamiliar to them, and they were trying to figure out, well, does this apply or doesn't it? As well as give recommendations for what is the most likely thing you should think about doing to improve your learning. So it's a sneaky way of actually doing training through the use and the joint connections between the whole community of instructional designers. And yes, it also introduced them to each other, because otherwise they wouldn't have met. But now through that conversation and this process, so they began to converge as an actual community. And so, yeah, it was a process where it would be a product review document like this that had the strengths and opportunities. It also had summaries of raters' comments, so people could actually, see some points of things. And then it actually had, example screenshots to make a library, so that if you wanted to know, well, what does a good example of an assessment look like in this way, you could actually go find those. And that was just underway when I was leaving, was creating that catalog. And in addition to evaluation, you can look at scale. So Kaplan University, by the time this was actually done, had already run 150 randomized controlled trials in about 2 years. Think about that for a second. 150 randomized controlled trials in 2 years. That's not how education has ever worked. But that's how Amazon works. That's how Google works. In fact, these are small numbers. Over 2 years? Didn't you mean one day? But it can be done this way, right? When you run that many, you can actually look at a portfolio of innovation, and it looks a lot like an engineering portfolio. Well, most of this stuff is these tall bars here, where it's kind of inconclusive and no firm recommendation. And what that means is, we don't know, it doesn't seem to work, but we haven't given up yet. We're tinkering, we're trying again. Because again, stuff in the lab, applied at scale, doesn't work. Well, it doesn't mean it will never work, it just means there's something else going on at scale. So we want to tinker to see, can we get the active ingredient to actually work? Or is there something else that we messed it up? That we're giving an antibiotic to somebody with a cold, and we didn't realize that, right? It could be something like that where we have a mismatch. But we also did find things that absolutely did work, definite implementation recommendation, woohoo! But just as valuable are the ones, definite recommendation to not implement. right? Because that saves us time and money. It prevents people from doing worthless things and us spending a lot of money on stuff. So unlike a publication thing, in engineering land, negative results are just as important as positive results, right? And so you know, and then some are just kind of in the middle of things. We're in the middle of running trials and so forth. So powerful stuff. The last thing I'll show you, and I'll just do this very quickly. Also, when you're at scale, you can evaluate the quality of your assessments. So I'm going to show you. It's going to look like a horrible eye chart. I'm going to show you the result of doing classical test theory on a large data set of financial services questions. And this was used to actually look at those practice questions for the first time and see which ones are bad. And we didn't know that because they all looked good, face validity, but this is the data. So here, these are all these items split between item difficulty on one axis and item discrimination on the other, where discrimination means if you have good people, do they get them right? And if you have poor students, do they get them wrong, right? You'd like an item to discriminate that way, right? And what you see here is we had a bunch of items that were way too simple. We also had a few where they were negative discriminators, which means the good students got them wrong and the poor students got them right. That's not good. That's a problem, right? And then we had a bunch of items that were just way too difficult. Basically, nobody got them right at all, right? So this kind of repeated evaluation of your assessment items also gives you information that lets you now edit this and give you better and more information for the long haul. So all of this kind of work matters all the way up from exposure, then building education, then thinking deeply about the general management issues and how are you going to drive it all the way through, and then finally, at-scale repeated evaluation efforts if you're going to try to go after really good learning engineering. So thank you very much for your time and attention. I really appreciate it. All the best.